Section 3.2 and 3.3 is slope and slope-intercept formula. First, we tackled three forms of slope: rise over run when given a graph, change in y over change in x when given a table, and the y2 minus y1 over x2 minus x1 when given 2 points. After that, we look at the four types of slope. We have positive slope, we have a negative slope, we have a slope of 0, and we have an undefined slope. This is a horizontal line, and this one is a vertical line. These two pieces of information we need to know: x is a number, is a vertical line, and the slope is always undefined, up and down. Y equals some number is a horizontal line, the slope is always 0. Our first question they're going to ask is to find the slope when we're given these 2 points. We start with the formula that was given, and we're going to substitute those values in and solve. Y2 is equal to 5 minus y1 x2 minus x1. We're going to add our inverse here and here. 7 over 3. The slope of those 2 points is 7/3. Slope-intercept form is y equals mx plus b, where our slope is our m, our y-intercept is our b, but it's represented as the ordered pair 0, b. Our first problem, they're going to ask us to find the slope and the y-intercept. Well, if I write slope-intercept form over the top of my given equation, then it's easy to see that my m is 2, my slope is 2, and my y-intercept is 6, but it's written as the ordered pair 0, 6. This second equation isn't solved for y, so we have to get y by itself first. So I'm going to move 5x to the other side, and I have y equals 5x plus 10. My slope is going to be 5 right here, and my y-intercept is 10, but it's written as the ordered pair 0, 10. My third equation, y equals 2, is a special case. That's a horizontal, because I remember that. Horizontal, which is this. My slope is 0, and my y-intercept is the ordered pair 0, 2. Next, we're going to find out parallel lines have the same slope, and they look like this. Perpendicular lines have opposite reciprocal slopes, and they have that graph. Determine whether each pair of lines are parallel, perpendicular, or neither. And to do that, all we need to look at is the slope. We compare the slopes of the given equations. The slope of this first equation is 5. Slope of the second one is 5. So when we compare those are the same slope. Parallel means it has the same slope. Equation number 2, whenever I'm comparing the slopes, the slope of the first one is 2, the slope of the second equation is 1/2. They're definitely not the same, so they're not parallel. To be perpendicular, they have to be opposite, one positive and one negative. It fails that, so since it fails both of them, it's parallel, and it's not perpendicular, it's neither. Our last one, these equations are not solved for y yet, so I'm going to stop for a second and solve both of these for y. Once both of them are solved for y, we're going to compare the slope of the first equation is 2. The slope of the equation in blue is negative 1/2, so they're opposite. One's positive and one's negative, and they're reciprocals of each other, so this is perpendicular. My next problem asks me to find the slope of the line parallel. Parallel just means the same slope as this one. Well, this slope is negative 7 over 2, so all I need to do is use the same slope and say the slope is negative 7 over 2. My next problem asks me to find a slope of the line perpendicular. Now, perpendicular means opposite reciprocal of this slope. Before I can start, I have to solve this for y, so I'm going to take a minute and do that. Now, check your work in red and see if you got the same thing when you solve for y. After we solve for y, all we need to know is the slope of this. Now we want a perpendicular slope, so we want an opposite reciprocal. Well, opposite of a positive is a negative, and the reciprocal of 3/4 is 4 over 3. So this is a perpendicular slope to the given equation. Next, they're going to ask us to graph the line through the point 3, 5 with the slope of -1, 3. So I go to the ordered pair 3, 5, which is over 3, and then up 5 is here. Start at the ordered pair 3, 5, and then if the slope is that's -1/3, it's going to be down 1, right 3. So from that one, I'm going to go down 1, right 1, 2, 3. Down 1, right 1, 2, 3. Okay, so then I'm going to also graph a line through it. Number 2, it says graph y equals -2x plus 3. Well, the slope of this equation is going to be -2, which is the same thing as -2 over 1. And the y-intercept is going to be the ordered pair 0, 3. I'm going to start at my y-intercept 0, 3, which is right here, and now I'm going to apply my rise over my run. So I'm going to go down 2, right 1, down 2, right 1, down 2, right 1, and then draw a line through that also. My last graph says graph 7x minus 2y equals 10. The first thing we have to do is solve for y. So if you look over that and I divided it, my result when I solved for y was this. Of that equation, my slope is 7/2 and my y-intercept is the ordered pair. It comes from this 0, -5. So I want to graph that. I start at 0, -5, which is here. And now I want to rise over run. I want to do my rise over my run, so it's going to go up 7, right 2. But since I can't, from here I can't go up 7, then I'm going to go in the other direction, which is the same thing, down 7, left 2. So from here in blue, I'm going to go down 7, 1, 2, 3, 4, 5, 6, 7, and to the left 2, 1, 2. And draw a line through it. So recall that if you run out of room on the graph that you can change direction, because remember a negative divided by a negative is still a positive, so all this is allowing me to do right here is just change directions.